Hello and welcome. Today I'd like to take a deep dive into the Headless Meeting Bot for Linux sample app that we've created. If you haven't followed along in previous videos, I recommend going back and looking at our introduction to the sample app. That'll get you started and off the ground as soon as possible. If you're following along here, you should already have the sample app up and running and be able to join meetings with it using that Docker compose up command. So in this video, I really want to take a look at some of the files that are involved in this project, and as a developer, how we can understand and even change some of those files to really get the most use out of the sample app and use all the features that it has available to us. So if you look at my screen here, you can see that I already have the Docker file open. And I think this is a good place to start in order to understand just how this sample application works. We have a few layers here in our Docker file. We're starting off with the base layer, where we'll install dependencies. So these are some of the base dependencies needed by the OS, needed to build a C++ program, as well as build the Zoom SDK. So we have CMake, we have G++, we have various compilers. So this is the base OS. Finally, we'll move on to install ALSA, which is important for recording raw audio data. And finally, Pulse Audio, which is uses ALSA to basically hook into the Ubuntu audio system and again, record raw audio data. Finally, we're installing Teeny as an init system that really just makes it smoother to pass signals back and forth between the Docker container and the host OS that we're using. So if I wanted to send a Control-C signal to stop the program, then we make sure that it's received by the CLI that we're running inside our container. Finally, we have our deps layer. So this will install C++ dependencies, specifically using VC package, and make sure they're available within our container. And then finally, our build layer, we will use our init system to execute our bin/entry script. So I think that's a good time to take a look at what exactly this entry script does. So we go up to the top, we can see we have a few functions here. We have a function to set up Pulse Audio to make sure that audio is configured within our container so that we can record raw audio. And then next we have a function where we can build and make sure that we set up Pulse Audio. So we'll generate some basic files for the CMake build. We'll copy over that shared library for the Meeting SDK. We'll set up Pulse Audio, and then finally we'll build our CMake program. Sorry, we'll build our program using CMake. And then next we have our run function. So our run function will just execute the command line program that we've just created. In the previous video, you may have saw that you can configure some options through the config.ini file. If we look at the sample.config.ini, we can see by default we have a display name and a file for that raw audio chosen for us. Now, what may not be clear is all the options in this config.ini file can also be set via the command line. So if we look at our entry.sh, we could, for instance, give it a help command just to see what is available to us. And then I'm going to run docker compose up. We'll start up our container. Here it's checking VC package to make sure we have our dependencies. Because we did change the script file, typically it wouldn't rerun that. And then it's going to go ahead and build out our program. Because we've given it the help directive, looks like it actually joined our meeting because I forgot to save this entry file. So I'm going to deny recording, and I'm going to leave this meeting. And here we can see a good example of it catching that Control-C signal. So let me just make sure I save this entry script. We'll run docker compose up once more. And now you can see it executed that help option for us. So if we look at the help option, we get the name with the version along with the usage of our program, and we can see some various options that we can use. for the program. You'll notice that there are also subcommands that can be used here. And a lot of this is probably familiar if you've looked at the sample config ini file. For instance, that file has options for client ID and client secret. It also has an option for a join URL. And any of these options here that you see available could be added to that config.ini file so that you can make use of these features. So let's take a look at the raw audio subcommand. So how would we do that? Because it's a subcommand, you can type in raw audio right here in the command line or to execute on the command line with our program. And I'm going to pass that the help option so we can see what's available to us with the raw audio subcommand. Great. Now I'll run Docker Compose up again. It'll build our application, but now this time we're going to use some different command line options. So now we're being shown the help page for that raw audio subcommand. So you can provide it with a file to output PCM audio to. You can give it a separate directory to output that file to. And finally, you can separate participant audio so that you have different files created for each participant. I like that. So let's take a look at what that would look like if we enabled it here. So as you can see, we have options set in different places. So we have some options that are being set by the config.ini file that we've created. And then here I'm setting the separate participant audio option. And these will both work together so that at the end, we have all those options set, both from the command line and the config file. So let's go ahead and run Docker Compose up. So now it is joining the meeting once again, and it's requesting local recording privilege. So I'm going to allow that. And now instead of writing out to a meeting audio.pcm file, we have separate PCM files for each participant in the meeting. Awesome. So I'll use Control-C here, and our bot leaves the meeting, and we'll go ahead and destroy that container. We'll see if we look on our project files that we have a build folder that was created from building our CMake application. We also have an out folder that was created from those PCM files. So let's take a look at what exactly is in this PCM file using a program like Audacity. So I have Audacity open right here, and this is an open source and free to use audio program. So let's go ahead and import the audio that we have. We'll want to use the import raw data option up here. Perfect. And so we can see that we've already been placed into that out folder with our project, and we can see that we have our PCM audio file here. I'll click to import that. And we'll want to make sure the sample rate right here is 3,200 kilohertz. Sorry, 32,000 kilohertz. Everything else here, you can probably leave default as long as you have a signed 16-bit PCM file. Perfect. We'll import that, and now we can see we have the waveform for the audio that we've recorded. Let's listen to what it has to say. I'm going to allow that. And now instead of writing out to a meeting audio.pcm file, we have separate PCM files for each participant in the meeting. Perfect. So we were able to write out that audio file as a singular participant audio, and we're doing that using the command line in a combination with the config file that we have. So as you can see, there are a variety of different configuration options that you could use in order to make the most of this sample application. I think another important one is to be able to provide it with a join token so that you're not always prompted with that local recording permission window that we see when we join the meeting. So go out there, experiment with the app and see if you can get that join token working. Thank you so much for joining me, and happy coding.